Okay, in this session, we're going to learn the graphs of the sine and the cosine functions. So graphs of the sine and cosine functions. We're going to work one by one. We're going to work on the sine first, and then we're going to do the cosine, okay? So if y equals sine x, okay, so let's think about the graph. All right, now we know that when x equals 0, y equals 0. So here's a unit circle. All right, so that's the unit circle. When x equals 0, y is 0. And when x equals, this theta, this angle, we call that x, okay? So x is not this x. This x is the x coordinate of this circle, of the point. But now this x is actually the angle. Okay. And when x equals pi over 6, which is a 30 degree, then the sine of 30 degree, that's my x. Okay, sorry, not this. So that x, pi over 6, a 30 degree, this lift up by 1/2. Y is 1/2. And when x is pi over 4, that's a 45 degree, and that y is square root of 2 over 2. And when x is pi over 3, that is a 60 degree, then y is root 3 over 2. And when x equals pi over 2, that's exactly 90 degree, then my y will be 1. All right, I can continue because remember this is the sine of this x, okay? So when the x equals 0, the lift or how much it goes up from the x-axis is 0. Therefore, it goes from 0 all the way to 1 when x goes from, or the angle goes from 0 to 90 degree or pi over 2. And in the other way, see, when x keeps growing up from pi over 2 all the way pi, the lift, this part, will go from 1 down to 0. And then from 0, keep going, 0 to -1, and a -1 back to 0. Okay, so if you graph that, because I don't want to just write the detail here, but I can show you the graph of the sine function, and when x equals 0, and when x equals pi, and when x equals 2 pi. Here, pi over 2, which is 1, and this is -1, so you have multiple points look like this. It's interesting, this is the graph of the sine function. So y equals sine x. If you graph that, it looks like this. This is the angle x measured in radian, and then this is the y value, which is the sine x. And if you keep going, it's going to repeat, isn't it? It's going to repeat, and here it's going to repeat and repeat. All right, now this is the new function. We have never seen this kind of a graph before. So this is a periodical function. In this case, the maximum value equals 1, the minimum value equals -1, period, equals, see, here's the period, 0 to 2 pi, right? And then repeat for every 2 pi. Okay, and what else? There's one more thing, I don't know if you remember that we learned in the PreCal 1. Is what is an even function, what is an odd function. The odd function, that means f of a negative x equals negative f of x. Did you see that? When x equals pi over 2, y is 1. When x is negative pi over 2, y will be, -1. Okay, so that agrees with this. So sine function is an odd function. All right, now after we learn this is the graph of y equals sine x. Now let me ask you another question. Can you graph y equals 5 sine x. Based on what we have learned in the pre-calc 1, we learned the transformation of the function. If there's a coefficient before your parent function, 5, which means you're going to stretch vertically by a factor of 5. So your graph will look like this. Instead of having 1, you stretch it to 5 and a negative 5. And then again, the period is not changing at all. So you're going to have something look like this. And then you keep going, right? Right. So see, instead of the minimum is -1, positive 1, minimum is -1, maximum is +1. Now we have from -5 to 5. So we're stretching this function vertically by a factor of 5. So that is this 5. And we call this as the amplitude. That makes sense because we enlarge that or shrink it by that factor. All right, what about -5? Y equals -5 sine x, which means we're going to stretch this by a factor of 5, then we're going to flip along the y-axis. So we're going to have from -5 to +5, and then keep going. Sorry, it should be look like this, from -5 to +5, -5 to +5. Looks like this, right? Always start from here. This graph is wrong, don't worry about that. So that is from here. You see the difference between these two? You just flip it, you get a -5. And in this case, we call them, see the minimum is -5, maximum is +5, and then this amplitude is also 5. You might want to say -5, no, but when we talk about the amplitude, we only take the absolute value of that, so it's going to be just 5. Okay, so something more. Parent function. Function is y equals sine x, right? Okay, what about this? What about y equals 5 times sine x minus pi over 2? This, I know how to deal with that. For sine x, goes from 0, 0, go up and down like that, right? So I just keep this in mind. If I multiply by 5 in front of that, I'm going to enlarge that, or I'm going to stretch that vertically by a factor of 5. But what I'm going to do with this x minus pi over 2, remember here's a pi, here is 2 pi, right? That's 1 period. And then if here is x minus pi over 2, which means I need to shift to the right by pi over 2. Therefore, here's a pi, so here's a pi over 2. If I move this or shift this to the right, so I'm going to start from here's a pi, here's 2 pi. I'm going to shift this point to here because I shifted the whole graph to the right by pi over 2, and then here's going to be 5 and a -5. Did you see that? You shifted this pi over 2, so, and then you're going to end this point is going to be 2 pi plus a pi over 2, like a 2.5. So it's going to be look like this. It's going to meet here. So okay. And of course, if you like, you can just extend that. But you get the main part. So this is a 5. That's the amplitude, which means vertically it's stretched by a factor of 5. And here you get a pi over 2, negative pi over 2. Did that give you the starting point of your period? See, the starting point here is a 0. But this, since you shifted to the right, so your starting point is pi over 2. So starting point of 1 period will be just pi over 2. Be very careful, there's a little difference here in the sign. All right, now let me do one more. Can you draw 5 sine 2x? here is 5. The parent function look like this, right? From 0 to 2 pi. It's one period. That's a sine function. And if I have a 5, I have the amplitude 5, so I have this, right? But what about this 2x? This 2x here means the original parent function starting from 0 to 2 pi, that is one cycle. But if you have a 2 here, that means when x goes from 0 to pi, you already finished one cycle. Think about that. When x goes from 0 to pi, you double that, so the whole thing here will start from 0 to 2 pi. That is one period. So your period in this case is going to be pi, not 2 pi anymore. So you squeeze that. You squeeze that from here to here, you finish the cycle. Okay, so your period is pi. All right, now the last one. What about y equals sine x plus 3? This is very easy, right? You have the parent function. It goes like this. If you plus a 3, you just shift up. Here's a 1, then 2, 3. So shift up by 3. So that's this. And then that, in this case, the parent function, the midline, is y equals 0. But in this case, your midline is y equals 3 because you shift up by 3. All right, now I'm going to tell you a very generic form. Okay, so if f of x equals a sine b x minus c plus d. This is a very general form of a sine function. And this a, the absolute value of a, this is the amplitude. Okay? And if you know b, think about here. If you have a 2, then the period is pi. So the new period is 2 pi over b. This is a very interesting, right? Okay. And your starting point is when x equals c. So, or it's equivalent to shift graph to the right by c. Of course, if c is negative, then you shift it to the left. So, for example, if you get x minus 5, then you're going to shift f to the right by 5 units. Okay. If it's x minus 3, then you're going to shift it to the left by 3 units. Okay. Okay. At the end, you have this d. D is the midline, which is y equals d. So that means you're shifting up or down by d units. All right, so that is everything you need to know. How to use A, B, C, D, and then how to graph it. This is super important. All right, now I'm going to give you some example. I just ask you to spend a couple of minutes to write this down because this is a super important. Okay, and I'm going to ask you to do this. Can you graph f of x equals 5 sine 3x minus 6 plus 8? Can you graph this? First of all, we have to pay attention to here. This is b times x minus c, which means we got to factor b out. Factor this 3 out. So that's going to be 5 sine. Okay. If I factor 3 out, I get x plus 2, sorry, x minus 2 plus 8. So what do we know from this? First of all, we know the amplitude. Amplitude equals A, which is 5. So far I know A is 5, B is 3, C is 2, and D is 8. Remember this is negative C or minus C, so my C is 2. Okay, so I have the amplitude is that, and what is my period? Period is 2 pi over B, which is 2 pi over 3. Okay, so 2/3 pi is my period. That's not bad. And my starting point is x equals 2. Okay, and my midline is y equals 8. So that's all the information I have. All right, and think about here. This is the absolute value of A, and A is 5, so there's no flip around. We don't need to worry about the flip the graph. If A here is a negative, then we have to flip the graph. Okay, now, at least I know a lot of things. I know my starting point is when x equals 2, and my period is 2 pi over 3, which is 2 pi over 3, so that's going to be, here's a 2, and then here is a 1, 2, here's a 3, and here's about a pi, right? So 2 pi over 3, so it's like a 2/3 of that. It's about this much. So from 2, I go here, and I go here. This is 2 plus 2 pi over 3, and here's 2 plus 2 plus 4 pi over 3. That's 2 periods. But anyway, so that's it, okay? And then I have the midline, which is 8. Here's 8. And the amplitude is 5. If the amplitude is 5, that means it goes from A plus 5 and A minus 5. So my graph is going to be in this range. All right, and my starting point is x equals 2, so I'm going to start from here. And the period is here, so I'm going to stop. And then I have the graph should look like this. That's one period. Once you draw one period, then it's easy just to continue to draw another period, or you can just do one more period. But this is basically, you can tell from the graph. And of course, if you are given a graph, and then this is how you identify your A, B, C, D. You find the maximum and the minimum. The difference between the maximum and the minimum should be twice of the amplitude. Okay, and then if you determine you want to use a sign, if you don't want to, if you want to have a positive A, you're gonna start from here because it goes up first and then down and then go back. But if you want to change from here and then go down first, then your amplitude is going to be -5. So that's another little thing you're going to pay attention to. And also from the graph, you find from here to here, that's one period. Then you figure out how much is this. Okay, your period should be 2 pi over B, and then you can calculate it B. That's your the B, and then your starting point, which is here, which is when x equals 2. That's your -2. That's 2. That's your C, and then the last one is the midline that tells you the D. Therefore, you have A, B, C, D. Okay. So that's how you determine this A, B, C, D, and how to graph it, or how do you read from the graph to find the A, B, C, D, and then go back to this graph. Okay, so let me give you another example. So f of x equals -2 sine 4x plus 2 pi. And then plus 1. All right. Can you find A, B, C, D and then graph it? So my amplitude, absolute value of A is this 2, and my A is actually -2. Don't forget you have to flip because you have a negative, okay? And what about your B? Because your period is 2 pi over B. That's my period. Okay. So A is -2, B is a 4, and the C is -2 pi, and my D is 1, right? Not really, because this, don't forget you have to take out this 4. You write that as a 4, take out a 4, so you get it divided by 4, so you have a pi over 2. Did you notice that you have to be very careful here, because you cannot just get a C equals -2 pi. I saw this mistake all the time. Some book write bx minus c, but I like it this way. I like my way better because it's very easy to tell. So my c is -pi over 2. Okay, now go ahead. I get a 2 pi over b, that is 2 pi over, my b is 4, so it's a pi over 2. And the starting point is x equals, starting point is x equals what? Is equals negative. Is my c negative? Okay, so it's a negative pi over 2. Okay, so my starting point is x equals c. So that's that. And the last one is the midline. There's no space. Midline y equals this guy. So it's 1, A, B, C, D. Okay, so when I graph, look what I'm doing. I would graph, see y equals 1. That's my midline. The amplitude is 2. So that's 1. So I go up by 2 and I go down by 2. So that's my maximum value. That's my minimum value. Okay. Okay. And then my starting point is negative pi over 2. Here's a 0, here's a positive pi over 2, here is a pi, and here is 2 pi, something like that. Okay, my starting point is negative pi over 2, and then my, here's the minimum line, here's the maximum line, right? Okay, and then my midline is this, starting point is here, my period is pi over 2. So starting from here, go here, that's 1 period. There's another period. There's another period. See, every pi over 2 is my period. All right. So when x equals negative pi over 2, I'm going to start, and then I'm going to stop here. It's interesting. So I need to graph like this. It's 1 period, and then goes from here to here. It's another period. Pretty narrow, but that shows the idea. Okay, and so far this is when a equals a positive 2, and don't forget you have a negative 2, which means you have to flip this. Therefore you're gonna have, if you flip that, you're gonna have, I mean you flip this graph, so you're gonna have this, you're gonna have because you enlarge this, if you enlarge the original twice, and then you're going to flip it because here's the negative 2, and that's your final graph. I know it's very confusing, but I want you to take a look and then try to do this by yourself. There's so many places, it's so easy to make mistake, so be super careful. Okay, and then in the last, I'm going to give you one real example. This is the real example. It takes some thinking, okay? A Ferris wheel. A Ferris wheel that has, let me think. I just made this up, okay? A Ferris wheel with the diameter 30 meters, which infers to the radius 15. Okay, just keep this in mind. Okay, and that's this. Okay, it starts from the platform, which is a 5 meters above, because So there's some stairs, and the people have to climb up all the way up to here to take that. And then you're going to go around, right? It's going to go around, and then come back for every 10 minutes. I ask you to show me the height of you once you get on board. The height of you as a function of the t, that's where 10 minutes after you boarded. Isn't it interesting? Okay, so here's a 15, here's a 15. Now, the height, what's the maximum height? And what's the minimum height? The maximum is going to be 35, right? And the minimum is 5. So the max minus the minimum is 30, and half of that, which give you the amplitude, 15, which is the same as the radius. So I know my A equals 15. Perfect. All right, now we think about the height. Usually, if there's a height, we probably think about the vertical up and down. And let me just use sine function, okay? Sine function. So f of a t, or the height, is a function of t, equals. First of all, I know 15, and I know sine, okay? And then I need to know b, and then I need to get x minus c, and then plus a d. What is a d then? The height, or the middle line, should be 5 and 15. So I already know this is 20. Okay, so next one is I need to find a b and a minus a c. Sorry, this is t. All right, now b, remember 2 pi over b is my period, which is 10 minutes. Can you find a b? Yeah, 2 pi over 10. So pi over 5. That's my b. That's my b. And my d is 20. I already know that. Now the next one, I need to find the starting point. For the sine function, the starting point is starting from here. The sine function. Remember the unit circle thing? I always start from here. The whole period is 10 minutes. So when you talk about the height up and down to get the sine, where is your starting point? That's when your time goes a quarter of this whole period, isn't it? That's 2.5. So starting point is when x equals 2.5 minutes, your function start coming in. What does that mean? Starting point, remember starting point is a c, so my c is 2.5. I have a, b, c, d. So let me write it. My f of a t, sorry, I shouldn't use x, I should use t all the time, okay? So that's going to be a 15 times the sine of b pi over 5. And then remember here it's x minus a c, so it's t minus a c, so t minus 2.5. And all together plus 20. This is my function. To show the height of me 10 minutes after I get aboard. So if I have a t equals 0, then this is a negative 2.5 divided by that. What do you have? You have a negative 1/2. So it's a negative pi over 2. Negative pi over 2, the sine function, sine of negative pi over 2 is negative 1. So here's negative 15 plus 5. You are 5 meters above the ground. Okay? And when t equals 2.5, so when t equals 2.5, this part is 0, and that's a 0, sine 0 is 0, times that is 0, so you're 20 meters above the ground, isn't it? When t equals 2.5, that means 2.5 minutes later, what's your height? 20. Here, 20. So that shows exactly the same position of you the height of you 10 minutes after you're bored. Okay, so we have learned everything so far for the graph of sine. Now the next one will be very easy. We're going to do y equals cosine x. All right, remember the cosine is the reflection of this angle down to the x. So when the angle starts from 0, your cosine is 1. And then when it goes up here, your cosine is this, gets lower. And that goes to 90 degree or pi over 2, your cosine is 0. And then if you go this way to the second quadrant, then your cosine goes from 0 to -1. And then if you go from here to here, like 180 to 70 degree, the cosine goes from -1, shrink back to 0, and then go back to here, go back to 1. So that means starting from when the angle is 0, you get a 1, and then you get this. Okay, so where is that? That's pi. And then keep going. Go back to 2 pi. This is the function, the parent function of, here's 1, here's -1. So this is the parent function or the function of just cosine x. Very similar idea. Okay, here is the starting point. The highest point, you're starting from the top high point. That's your starting point. And then what about this? Y equals A cosine B x minus C plus D. Amplitude, you enlarge that. A cosine, if it's a cosine function, you always graph from the top, okay? If here A is a negative, of course you flip it, so you graph from the bottom, you go up. B is the period. 2 pi over B is the period. I'm sorry. B tells you the period. Okay. And x equals C, that's your starting point. And y equals D, that's your midline. All right, and then this absolute value of A, that's your amplitude. Okay, so it's not bad, right? All right, I'm gonna just give you one more example so we can finish that. So let me just graph y equals twice of cosine 2x plus pi and then -1. All right, now A is 2, B is, be very careful here. I have to write that as x plus pi over 2. So I can get this form. I get a B equals 2. Therefore, my period equals 2 pi over 2, which is pi. Okay, and my C is negative pi over 2. Right? C is the opposite sign of that. And my D is -1. All right, so what do I know? First of all, see the midline, -1. That's the midline. And the amplitude 2, so I go up by 2, and I go down by 2. So all my graph should be bounded by this 2. That's -3 and a +1. Okay, so that's y, and that's x. Okay, now starting point. Starting point is negative pi over 2. Here's negative pi over 2, and here's negative pi, and a 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, my starting point is x equals negative pi over 2. So negative pi over 2, that's where I'm going to start. Remember, I start from the top. Okay, since my A here is positive, I start from the top. And each period is pi, so it's going to be from here to here. From negative pi over 2 to positive pi over 2. So I will go like this. Okay, and then pi is my period, so I will go from, After you draw one period, you can continue to draw another one. Okay, so use this as the example. Then you might want to try this by yourself to see whether it works. And again, A, B, C, D shows exactly the same meaning just as in the sine function. Okay, so this is everything you should know for the graphs of sine and cosine functions.